come in. Oh, hi, Rollo.
Hey, Dr. C. Listen, I got a question about threads, and I wonder if you could help me.
Sure, what's the problem?
Well, I have these threads, two threads. One is searching the internet for possible subscribers to my mailing list, and I have another thread that is picking up this data, but it seems to be in a state of frozen mentality because it never responds anymore. Maybe I have deadlock or something like that. I don't know.
Well, come on in. Let's have a look at what you got. And let me show you some stuff that I have put together about thread coordination that might help. So do you want to look at thread coordination with notify and wait?
Well, I was using Notify, and my thread seemed to be waiting forever.
Well, so I think maybe your problem is what's something called the producer-consumer problem. And here's how it works. There's a speedy consumer and there's a speedy producer, and that is the problem with threading, especially when you're trying to coordinate them. It's kind of like you're running a race and one person jumps out in front of the other and is traveling too fast and they shouldn't be. So let's see how this works out. So if we begin with the speedy consumer problem, assume that you have a cubby, a place where some data is put. And so you're going to have threads that act as a producer, and they're going to be putting some data into the cubby, and then you're going to have another thread that's going to act as the consumer that's going to take data out of the cubby. So what you have is the producer thread puts the data in this shared area, and the consumer thread then comes in and gets it.
Well, that's exactly what I'm trying to do.
Well, the problem arises when the consumer thread runs faster than the producer thread. That is often the issue. So let's look at what may happen. The producer is going to put some data into the cubby, into the data area. Let's say they put a 99 in, and then the consumer thread gets activated, and the consumer will get that value.
Well, that's perfect, but what may go wrong?
Well, what may go wrong is since your consumer is speedier than your consumer is going to come back and get the same value out. It's going to get duplicate values. Remember, when a consumer extracts data from a data area, it often doesn't simply overwrite it with zeros or whatever, but simply gets the same value. So this is the downside of a consumer thread operating at a faster cycle or being selected by the operating system over the producer thread. Now, the problem extends the other way too. You can have a producer that is speedier than the consumer. So let's look at that. Here you've got your producer, put some data into the cubby, 99. Consumer thread is not doing anything yet. It's kind of slow. And the producer thread, which is so fast, puts another value in before the consumer has come and taken the data out. So the speedy producer is simply producing, and the consumer shows up every once in a while and only gets some of the values. So this is the big challenge of coordinating with threads. Each put will overwrite the previous one, and then when the consumer comes and gets what's in there, it's only going to get the most recent one that the producer has put into the cubby slot. The bottom line is the consumer is going to miss the values. So let's look at the ideal situation. It is going to be when the producer puts some data in, the consumer gets that piece of data out. And then the producer puts another one in, and the consumer gets one out. So we need to have each put followed by a get. And that's the problem. That's the challenge. How can we guarantee that? Well, Java provides several thread coordination methods available. And these are called wait, and then there's a notify, and then there's a notify all.
I was using those, but then my threads never responded.
Well, okay, let's look at what the problem might be. But first, in order to understand the solution, we need to review a concept about Java objects. So each Java object has a lock that can be obtained and released, and we've seen how an object's synchronized method allows a thread access to this. But behind that synchronized is a lock, and every object has a lock. Now, in addition to that, each object has a waiting area where threads that block wait until some other thread comes and wakes them up. And this is where wait and notify come in. So these are methods that we're going to be calling on our Java objects to control what happens in the waiting area. Now, a couple of technical details on wait and notify. So wait is a method. When you call wait, or when a thread calls wait, it must hold the object lock via synchronized method or a block. So think of this lock as something that the thread needs to grab in order to call wait. Okay? If it doesn't do that, then an exception will be thrown, and we don't want that.
Well, I get plenty of those.
Yeah, well, that's not a great thing to have. The lock is released when wait is called. So this is a little tricky. The thread has got to own the lock, but once the thread calls wait, it's thrown into the waiting area, and the thread is blocked, but the lock is then available for another thread to come and get. That's kind of the tricky aspect of this. Now, when notify is called, a thread must own the lock on the object. It will call notify, and then any threads that are in the waiting area, one of those threads will be arbitrarily chosen by the scheduler to be unblocked and come out of the waiting area.
Wow, so like freedom from the pen.
Well, that's kind of right, Rollo. Now, the release thread now is sort of floating around in the thread space, and in order to do any work, it's got to re-obtain the lock. So when the thread calls wait, it owns the lock, it goes in the waiting area, it then needs to hang around for someone to call notify, and then gets released, but it's got to reacquire. And when it gets the lock, it will resume from the point where it called wait in its code. Now, in addition to notify, there's notify all. So notify, there's a bunch of threads waiting, one gets picked. In notify all, they all get released.
Wow, like a jailbreak.
Well, kind of. They get released, and then they must contend for the lock. So this is how it works. Now, to make this all work, we've got to have a protocol. And here is the protocol. The producer, instead of just throwing the data into the cubby, it deposits the data and calls notify or notify all. That is the way we've got to structure it. The consumer, before it tries to retrieve data, must call wait. And if we do this, we can sort of solve the problem.
Well, I was doing that, but things didn't seem to work out.
Well, there are some issues to be aware of, and so here's the problem. The difficulty. So here we have a producer thread, we have our consumer thread. The producer puts something into the cubby using the protocol. So it acquires the lock, it puts the data in, and then calls notify. But the consumer hasn't even shown up yet. So the producer puts the data in, says, anybody want it? Come and get it, and then leaves. Now, the problem is the consumer comes along, and its protocol says, well, before I want to actually get the object, I call wait. So the consumer now calls wait. But the producer may never show up again with some data. So the consumer is going to sit in the pen is going to sit in the waiting area potentially forever until a producer comes back. So if it's just a one-shot deal, this consumer thread will never be able to get out of that waiting area. And then you have what is in effect a deadlock situation.
Well, maybe that's what happened to my thread. How can we fix this?
Well, there's a way. There's always a way in software. We need the producer to set a flag. So we need another piece of data, a Boolean, to say whether there is data in the cubby or not. And that's how it's going to work. If the producer comes in and sees that there is data waiting in the cubby, the producer's not going to do anything. It's going to wait. If the consumer comes along and sees that there is no data in the cubby by looking at the flag, then the consumer is not going to try to get the data. So let's see how this plays out. So here's one way to think of it. You've got this Boolean flag, like a little green flag, to indicate that there's something in the cubby. So the producer will set the flag. The flag will begin not green, red, false. And when the producer comes along, and this is another dimension of this that can be a little tricky, when the producer comes along and sees that there is something in the cubby, it doesn't want to overwrite, so it will call wait. And the producer is going to wait around until somebody notifies it and comes out of the waiting area. So when we start, there's nothing in the cubby, and it has no value, and so the initial state in our code is going to be the Boolean is going to be available. The Boolean value, which is named available, is going to be false. So then the consumer comes along, or consumer thread, before it calls get on the cubbyhole, looks at the flag. If the flag is not available, we want the consumer to wait. So what does this look like? Well, here's some code. So we've got the get method is going to be synchronized. So that means the thread must own the lock even to try to get it. Okay? So let's say that the thread gets the lock. It comes in, and while available is false, it's going to wait. So if there's no data available, it's going to wait. It's going to sit there and basically suspend. Then, assuming somebody comes along and calls notify, it wakes up, has to reacquire the lock, and now continues right here. So if available is now going to be true, it immediately sets the available flag to false, calls notify all to get everybody else aware that it's acquiring the data, and then returns the value. From the producer side, when the producer wants to put something in, it must acquire the lock. So it needs that so that's why we make the method synchronized. It has the same basic logic, but it's a little flipped. While available is true, which means there's something already in the cubby, it will wait. And then when somebody calls notify, it is then ready. It resumes down here, sets the value to the parameter that it was used to pass the put, sets the available flag, and calls notify.
Well, that's kind of complicated. Can you show me an example?
Sure, Rollo. So let's imagine that we have two threads that are trying to get stuff out of the cubby, and we have a couple of threads that are trying to put stuff in the cubby. So this guy is going to put the number 2 in, this guy is going to put the number 3 in. Now, these are 3 threads that are in runnable world. We know that in threading and with the scheduler that it's unpredictable who is going to be selected. So we're in this sort of non-deterministic world. So how is this going to work? Well, let's see. Let's say the first thread that gets chosen by the scheduler, is the thread trying to get something? Well, there's nothing to be gotten because the flag is false. So what do we do?
Well, you gotta wait.
Right. So this thread will essentially call wait, and he will be put into the waiting pen. There he is down there.
Oh, yeah.
So now he's still waiting. There's nothing in the the cubby, and now this guy, or producer thread, one of the producer threads gets chosen by the scheduler. So now the producer thread is trying to put 3 into the cubby. He comes in, he finds the flag down, which means there's nothing in there, so he will put 3 in the cubby. Now, you tell me, Rollo, what is going to happen when he puts 3 in the cubby?
Well, I think he will call notify.
That's right. He will call notify. Now, when that happens, he actually is going to call notify all, and we'll talk about that a little bit later. But basically, he will call notify, and our friend that was in the waiting pool will be, there he is, will be released.
Oh, get out of jail.
Yeah, kind of. He gets out of jail, and where does he go? He doesn't take the data out of the cubby. He gets sent back into runnable world because he's now just a thread competing for the CPU. But let's look at what happens if this guy, a producer, gets selected by the operating system when there's already data in the cubby. So he's going to come in, and he's going to see the flag that there's data in there, so he is going to end up in waiting world because he doesn't want to overwrite the data that is in the cubby. Okay, so now this guy is in waiting world, and now the scheduler is going to pick another thread. So let's imagine that he picks one of these guys that's going to do get. So he comes in, he finds the flag set, which means he can extract the data. So he can then get the data, and then he calls notify all, and so the thread that was waiting to put is now put back into the runnable world. And now if the get guy gets chosen, he waits, but if the put guy gets chosen, since the flag is set to false, he will put the data in. And so it goes.
Wow, so I need a flag to solve my problem because I find that these guys are just waiting around.
Yes, that's right, Rollo. So you need to do that. And so to summarize, be careful. Coordination is tricky. Threads are tricky, but notify and wait will allow you to coordinate your threads so you don't lose data and there's no threads hanging around chilling forever in the waiting area.
Well, gee, Dr. C, thanks a lot. I think I can maybe now solve my problem, and my threads will be able to gather up many names for my project. Thanks a lot.
Oh, okay, Rollo. Good luck with your project.
All right.